So let's formally define what a piecewise function is. It is a function that is defined on a sequence of intervals, and one of the most common examples that we see in math is the absolute value function. You've probably seen this function in a previous math class where you take the number inside of the absolute value symbols and just make it positive. Well, this is a more formal definition. It basically says that if you plug in a number into the absolute value function, it's that same number if the number inside is positive or equal to 0. However, if the number inside the absolute value symbols is less than 0, then we multiply it by -1. So, example 2 says, consider the function f of x equals the absolute value of x. Create an input-output table, or t-table, for the function f of x that contains at least 5 rows. So I will put x in this column and f of x in that column. We've been putting y, but f of x and y, they work the same way. So if I plugged in -4 into the function, we would have f of -4 is equal to, and it's either going to be -4 if -4 is greater than or equal to 0, or -1 times -4 if -4 is less than 0. Since the top statement is false, we're going to go with this statement here. And so -1 times -4 is +4. So I'm going to fill that in here. And that's just kind of a more long, convoluted way of taking the absolute value of something, but you're probably more used to just taking the positive, which is fine. So I'm going to fill in a couple more values. Okay. So part B asks us to use the table that we created to sketch a graph of our function. So let me fill in the axes here. So here's my x-axis, and here's my f of x axis. And so if we plug in 0, our output is 0. If we plug in 2, our output's 2. If we plug in -3, our output is +3. If we plug in -5, our output is +5. I can put in a few more ordered pairs. So our graph is going to look something like this. I'm going to draw my arrows to indicate that it goes on forever in both directions. And it basically makes this V shape. And notice that there are no negative values down here. Our values are only positive for our outputs. Okay, example 3 says, consider the function g of x equals x times x minus 1. Evaluate g of 4. This is another way of saying plug in 4 and see what the output is. This function that we have here is actually one that we saw in a previous outline, and it was related to the snail mail group sending letters. So in the context of that problem, this is actually saying, if we have 4 people in a group, how many total letters would be sent? So that's another way to think about this problem. So if I'm plugging in 4, everywhere I saw an x previously, now I just want to replace it with a 4 instead. And if we're following order of operations, I want to do what's on the inside the parentheses first. So 4 minus 1 is 3. And now I want to multiply 4 times 3, which is 12. So in the end, we say that g of 4 is equal to 12. So part B says create an input-output table for the function that contains at least 5 rows. Well, if I plug in 2, then we have 2 times 2 minus 1. And if I simplify that, that gives me 2. If I do 3, that would be 3 times 3 minus 1, which is 6. I already evaluated 4 to be 12. And then let's do 5 and 6 and see what those give us. So 5 times 4 is equal to 20, and 6 times 5 is equal to 30. All right. So I'm going to draw in my axes. This is x, this is g of x, and this was 1, 2, 3, 4. Oops, I ran out. Maybe I'll just increment those by 1, and then the vertical axis, I want that to go to 30, so perfect. Okay, so if I plug in 2, then my output is 2, which is about right there. If I plug in 3, my output's 6. If I plug in 4, my output is 12. If I plug in 5, my output is 20. And if I plug in 6, my output is 30. Now notice that this is not a straight line, and it kind of curves a little bit. And it looks something like that. Okay? It is still a function, although it's not a linear function. It is a function, and we'll actually talk about this type of function later in our class. All right, that's it. See you in a later video.